Hello. Hello, am I audible?
Yes, sir.
Okay. Okay. Good afternoon, everyone. So today we will see something about matrices. Okay. We'll see first some introduction, some basic information about matrices, and then we will solve some questions on matrices that are previously asked in your CET examinations. Okay. So is this PPT visible? Hello.
Yes, sir. Yes, sir. Visible.
Okay. 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 Thank you. First, what is a matrix? Matrix is a set or group of numbers arranged in a square or rectangular array enclosed by two brackets. So, how do you write a matrix? So, first we write two square brackets and then we write some numbers in between those brackets. That is called as a matrix. Okay, next. What are the properties of matrix? A specified number of rows and a specified number of columns. So, what is the number of columns in this matrix? First matrix, this matrix first is 3 cross 3 matrix. How do you write it? First we write the number of rows and then we write the number of columns. So how many rows are there in this matrix? First there are 3 rows in this matrix, therefore the, the number of rows is 3. So we write it first 3 and then the number of columns. Number of columns is also 3, therefore this is 3 cross 3 matrix. So in second matrix number of rows is 2, therefore this is 2 cross number of columns are 4, therefore 2 cross 4. Therefore the order of this matrix is 2 cross 4. So for this matrix there is only one row, therefore this is 1 cross 2, and there are two columns, therefore the order of this matrix is 1 cross 2. Okay, so this is m cross n matrix. You can see here that number of columns is n and number of rows are m, therefore the order of this matrix is m cross n. Each each element is denoted by this a I j. I through I denotes the row and j denotes the number of column. Okay, so I is the number of row and j is number of columns, so that is to identify the element. So what is a column matrix or a vector? Column matrix means if a matrix contains only one column. See, this is 142 or 1 comma minus 3. This is called as column matrix. A matrix which contains only one column is called as a column matrix. Then a row matrix. What is a row matrix? A matrix that contains only one row. Okay, a matrix that contains only one row is called as row matrix. There can be any number of columns, but the row number is only one. It is called as a row matrix. What is a rectangular matrix? What is a square matrix first? Square matrix means if its order is m cross n, m cross m or n cross n. See, if the number of columns and number of rows is equal, number of columns is equal to number of rows, then we call it as square matrix. What do we call it? A square matrix. But for this matrix the number of column is not equal to number of rows, that is m cross n and m not equal to n. This is called a rectangular matrix. Okay, this is called as a rectangular matrix. A rectangular matrix has different number of rows and columns. Okay, so here it is square matrix. What is a square matrix? If order is like this, if order is m cross m or n cross n, then it is called as a square matrix. For this first matrix, the order is 2 cross 2. We can see that there are two rows in this matrix and two columns in this matrix. So the order is 2 cross 2. In this matrix, number of rows is 3 and number of columns is also 3. So order is 3 cross 3. Therefore, matrix is a square matrix. So any matrix like this, if m is equal to n, if m is equal to n, then it is called as square matrix. Diagonal matrix. Now, what is a diagonal matrix? You can easily understand what is a diagonal matrix. What's a diagonal matrix? If only non-zero entries are diagonal entries, then it is called as a diagonal matrix. Here you can see the definition here. What is the definition? A square matrix where all the elements are zero. All the elements are zero except those on the main diagonal. So main diagonal entries should be non-zero, and all other entries like this one, they should be zero. All other entries except the diagonal that are zero, it is called as diagonal matrix. This matrix is 4 cross 4. You can see that this matrix is 4 cross 4. You can see that the diagonal entries are non-zero. All the other entries, this one here, all these are zeros. So we can say that this matrix is a diagonal matrix. Unit or identity matrix. What is a unit or identity matrix? It is also a diagonal matrix. But special one thing is all the diagonal entries are all the diagonal entries are 1. Okay, this is identity matrix for identity matrix of order 4. This is identity matrix of order 2. Okay, we use this to calculate inverse of any matrix. Okay, this is called as unit or identity matrix. Unit matrix or identity matrix, the entries that are diagonal entries are 1 and all the other entries are 0. So what is a null matrix or zero matrix? Zero matrix means all elements in this matrix should be 0. All the entries are 0. See, this matrix is 3 cross 1. Order of this matrix is 3 cross 1. For this matrix, the order is 3 cross 3. So these matrices are null matrices or zero matrices. All the entries should be 0. Okay. Now, triangular matrix. A triangular matrix. What is a triangular matrix? See, in this, for the first matrix, you can see that these entries. This is lower triangular matrix. This is called as lower triangular matrix. See, these entries are non-zero, but these entries are zero entries. Okay, these entries are zero. Therefore, this is called as lower triangular matrix. Lower triangular matrix. Okay, you can see triangle here. Okay, triangular shape. Okay, so this is also a lower triangular matrix. Okay, so you can also see this, say that these entries are above the diagonal. Okay, these zero entries are above the diagonal. All these entries are above the diagonals and those entries are 0. Therefore, this is lower triangular matrix. Here you can see that all the elements that are above the diagonal, that are these entries are 0. So this is also lower triangular matrix. Lower triangular. Here this is upper triangular matrix. Upper triangular. Okay, this matrix is upper triangular. You can see that these elements are below the diagonal and these entries are 0. So all the elements that are above the diagonal and diagonal entries are non-zero and these entries are 0. Therefore, this is called as upper triangular matrix. See here, this is one special example for upper triangular matrix. You can see that The lower triangular entries are 0 and upper triangular entries are non-zero. So we can see that what we can say, this triangle is upper triangular. Okay, this triangle is, this my matrix is upper triangular matrix. See here you can see the definition: a square matrix whose elements below the main diagonal, are all zero. So this is your main diagonal and all the entries that are below this diagonal are zero. We can say that the matrix is upper triangular. Next is lower triangular matrix. Same way we can identify this. Okay, what is the definition here? Is a square matrix whose elements above the main diagonal are all zero. So this is your main diagonal. All the entries above this main diagonal that are zero. Similar for this particular example, this is your main diagonal, and these are this one, and this one. These are entries above the diagonal, and those entries are all zero. So we can say that this matrix is lower triangular matrix. Now, scalar matrix. Scalar matrix. What is the definition of scalar matrix? This is your definition. A diagonal matrix. What's a diagonal matrix? Only the diagonal entry should be non-zero. All other elements except the diagonal should be zero. All the entries. See, these are non-diagonal entries. They should be zero, and only the diagonal entry should be non-zero. This is called as diagonal matrix. So now what is a scalar matrix? A diagonal matrix whose main diagonal elements are equal to the same scalar, So what is difference between a diagonal matrix and scalar matrix? A diagonal matrix means the diagonal entry should be non-zero. That is the uh, enough condition for a matrix to be a diagonal matrix. But what is the special condition for a scalar matrix? These entries, they should be equal. This one, and this one. See, in this example, you can first say that this matrix is a diagonal matrix. Okay. So element other than the diagonal elements are all zero, and the diagonal elements are, what are the diagonal elements? Diagonal entries are 6, 6, 6, and 6. Therefore all the entries are same, so we can say that this matrix is a scalar matrix. Okay, a diagonal matrix. What is a diagonal matrix? If these entries are non-zero, they should be non-zero, but in scalar matrix these entries should be equal. All entries should be equal, then it is called a scalar matrix. Now we will see some operation on matrices. Okay, some matrix operations. See, equality of matrices. When we say that matrices are equal, it's very easy. So A and B, these are two matrices. If corresponding elements, so Aij is equal to Bij, then we can say that those matrices are equal. So here one, here also one. Here you can say this two, every corresponding element should be equal. Then we can say that the matrices are equal. Next, what is same? A and B are equal. So you see, what will be the value of B11 if A is equal to B? If A is equal to B, what is the value of B11? It is 1. So if you are asked to find the value of B32, what is the value of B32? It is 2. Same. Addition and subtraction. Okay. Addition. How do you add two matrices? Suppose these are two matrices 2, 3, 7, 8 plus 7, 3, 2, 9. How do you add this? Matrix addition or subtraction, both are easy operations. Okay, multiplication is different for matrices. So how do you add this? You just add corresponding elements. Okay, 2 and 7. What is 2 plus 7? It is 9. 3, 6, 7 plus 2, 9. 8 plus 9, it is 7. This is how you add two matrices. Okay, so commutative law. So matrix follows commutative law. Okay, what is the commutative law? A plus B is equal to B plus A. What is it? If you add A plus B, and suppose these are two matrices, 2 3 4 5 plus 2 3 7 8. What is the addition of these two matrices? Suppose this is A, this is B. So addition of these matrices will be 4 6 11 30. Also, if you add B plus A, if we do B plus A, that is 2 3 7 8 plus 2 3 4 5. What will be the addition? It will be same as the first. Okay, 6 4 6 11 and 13. What does this say? This states that matrices follow commutative law. Similarly, associativity, associative law. Matrix also follows associative law. Okay, so if you do B plus C first and then add it to A, or you do A plus B first and then add it to C, all these both these values will be equal. They are equal to this A plus B plus C. This is called associative law, and matrices follow the same law. Okay. So A plus 0 is equal to 0 plus A is equal to A. That is what? Additive identity. What is additive identity in matrix? For 2 cross 2 matrix, 0 0 0 0. It is 0 null matrix. Okay. Additive identity. This is additive identity. What is for 3 cross 3 matrix? It is 0 0 0 0 0 0 and 0 0 0. This is additive identity in matrices. Okay. Now, scalar multiplication. What's a scalar multiplication? Suppose this is A. A is equal to 3729. So this is 3729, and you want to find 3A. This is what? A scalar multiplication of matrices. So A is your matrix, and you are multiplying it by a scalar 3. What is a scalar? 3. Okay. So that is 3 into 3729. So what will be the multiplication of this? You just directly multiply this number to every element in the matrix. Okay, so 3 cross 3, 3 into 3 it is 9, 3 into 7 21, 3 into 2 6, and 3 into 9 it is 27. Okay, this very easy to solve this. Okay, so scalar multiplication, you just directly multiply that scalar to every element in the matrix. Okay, now this is also x expansion of scalar multiplication and its properties. So A plus B, A and B are two matrices, then K into A plus B. If you calculate A plus B first and then multiply it to K, it is similar to you may K into A plus K into B. This is basic algebra. Okay, K into A plus K into B. Similarly, other statements can be calculated. Okay. Now multiplication of matrices. This is something different from basic algebra that we use for real numbers. Okay, so A cross B A into B. Suppose their matrix A and B. There are two matrices and you want to multiply those matrices. So there are few requirements in order to multiply these matrices. What are the necessary conditions? See here. If matrix A is is of order 1 in 1 cross 3, then B should be, see, the matrix can be multiplied only when this number, this second number of columns of first matrix should be equal to number of rows of second matrix. These two numbers, these two numbers should be equal. Okay, these two numbers should be equal. That is only when we can multiply two matrices. Okay, suppose you have a matrix 3 cross 4, 3 cross 3, and another matrix 4 cross 3. You cannot multiply. Suppose this is A, this is B. You cannot multiply these matrices. Okay, you cannot multiply these matrices only because this number is 3 and this is 4. So if this is not equal, you cannot multiply these matrices. This has to be equal. So if matrix is of order 2 cross 3, another is 3 cross anything, if it is 3, even if it is 3 cross 18, it will be, it can be multiplied. Okay, these two numbers should be equal, then you can multiply these matrices. Okay, and what will be the result? Resultant matrix, resultant matrix will be of order, will be of order this. Okay, 2 cross 18, 2 cross 18. So in this, okay, so this 3 and 3, this equality suggests that the matrix can be multiplied, and this 1 cross 1, okay, 1 cross 1 means the resultant matrix, that means the multiplication of a cross b will be a matrix of order 1 cross 1. Okay, so in this, if this value is 3, this is also 3, therefore this matrices can be multiplied, and the resultant matrix will be of order 2 cross 18. Okay, next, see here, 2 cross 1, what is said here? Not possible. Why? See, this is 1 and this is 4, they are not equal. So first matrix is of order 2 cross 1 and second matrix is of order 4 cross 2. The number of columns in first matrix is 1 and number of rows in second matrix is 4. They are not equal, therefore the matrix multiplication is not possible. In this, see here, you can see 2 here and here it is 6, therefore these are also not equals. Number of columns here and number of rows in second matrix, they are not equal, therefore matrix multiplication is not possible in second case as well. Now for the third case, now for the third case, the order is, for my first matrix it is 2 cross 3 and for second matrix it is 3 cross 2. So these two numbers are equal, therefore matrix multiplication is possible here. Okay, multiplication is possible. And what will be the resultant matrix? Resultant matrix will be of order, what will be the order of the resultant matrix? It is 2 cross 2. So see, this first number and last number, they suggest the order of resultant matrix. Okay, for order of matrix will be 2 cross 2, and these two numbers, equality of these two numbers suggest the matrix are multiplicable. Next, see, now I remember, what is I into a is equal to a. What is I means identity matrix. What is an identity matrix? The diagonal elements should be 1 and all the other entries should be 0. For 3 cross 3, what is the identity matrix? It is 1 0 0 0 1 0 0 0 1. Okay, this is identity matrix for 3 cross 3 matrices, and this is identity matrix for 2 cross 2 matrix. Okay, so what is the multiplication of any matrix by identity matrix? What do you get? You get the same matrix. Okay, you get the same matrix. So this is called, that is why it is called as identity matrix. It is identity, it is multiplicative identity. What do we call it? Multiplicative identity. It does not have any effect when it is multiplied to an matrix. Okay, see this matrix is multiplied by identity matrix, it doesn't change its values. Okay, nothing is changed, same matrix we get as a result. That is why it is called as multiplicative identity. Next, here, okay, so we will see some products now. The this matrix is Matrix T, this is matrix S. What is T cross S? See, what is T? 1250 and S is 3402. So what is T cross S? How do you write this? TS will be what? So first 1 into 3, 1 into the first row, first column. For first element, we will write first row, first column. That is 1 into 3, 2 into 0. That is 3 plus 0. Second, first row, second column. This is first row and second column. That is 1 into 4, that is 4, plus 2 into 2 also 4. Now for this element, second row, first column, that is second row, first column, that is 5 into 3, 5 into 3, 15, plus 0 into 0, 0, that is 0. For this element, we will calculate second row into second column, that is 5 into 4, that is 20, plus 0 into 2, that is 0. So what is the result? 3, 3, 8, 15 plus 0, 15, 20 plus 0, it is 20. So this is TS. This is the value of TS. Now what is ST? ST. So we will first write ST 3402 now and 1250, 125 and 0. Now what is the product of S into T? This first row for this element, first row, first column, 3 4 into 1 5, that is 3 into 1, it is 3, plus 4 into 5, it is 20. For first row, second column now, 3 into 2, it is 6, 4 into 0, it is 0. Now second row, first column, 0 into 1, it is 0, plus 2 into 5, it is 10. Now second row, second column, 0 into 2, 0, and 2 into 0, also 0. So 3 plus 20, it is 23. 6 plus 0, it is 0. 0 plus 10, it is 10. And 0 plus 0, it is 0. Now what can you say from this? That TS is not equal to ST. Okay, TS is not equal to ST. Okay, for suppose, so you can say that for any, if two matrices are given A and B, then AB is not always equal to BA. Okay, it is not always equal to BA. It is generally not equal to BA. Okay, so in scalar products, in real numbers, why? If A and B, A comma B are real number, we always get what? AB is equal to BA, but not for matrix. Okay, not for, it is not valid for matrices. Okay, now AB. Now if AB is equal to 0, neither A nor B necessary is 0. Okay, what can you say? If AB, if AB is equal to 0, neither A nor B necessarily is equal to 0. So suppose A comma B are real numbers, scalars. What can we say about this? If AB is equal to 0, then either A is equal to 0 or B is equal to 0. In this happens in real numbers. Okay, this happens in real numbers, but for matrices, see, this is a non-zero matrix. Okay, this is non-zero matrix. Also this also is non-zero matrix, but their product is 0. See, 1 into 2, it is 1 into 2, it is 2. 1 into 2, 2, plus 1 into minus 2, it is minus 2. Now first row, second column, what is first row, second column? 1 into 3 is it 3. 1 into minus 3, it is minus 3. 0 into 2, 0 into 2, it is 0, plus 0 into minus 2, 0. Then second row, second column is 0 into 3 is equal to 0. 0 into minus 3 is equal to again 0. So what is the result? It is 0 0 0 0. So therefore you can see that the product is 0, but neither of the matrix is 0. Okay, neither of them is 0 matrix. Both are non-zero matrix, still their product is 0. So that is a property of matrix. Now transpose, these are important things now. Okay, What is the transpose of matrix? Suppose this is your matrix A, 2, 4, 7, 5, 3, and 1. So what is the order of this matrix? Order of this matrix is 2 cross 3. 2 cross 3 is the order of this matrix. So how do you write the transpose of this matrix? You simply have to write, suppose this is the first row, you should write this row as a column. How do you write it? 247, 247. Write 247 as a column. Okay. Now second, what is the second row? It is 531. You write it as second column. Okay. 531 is second column. The order of this is 3 cross 2. So you can see that if a matrix is of order 2 cross 3, its transpose will be of order 3 cross 2. The order is interchanged. Okay. And also the first row is written here as first column, second row is written as second column. That is how you write transpose of any matrix. Okay. See here again, same. Symmetric matrices. What is a symmetric matrix? See, a square matrix. What is the definition? A square matrix is symmetric. When it is symmetric, if it is equal to its transpose. What is meant by that? When A is equal to A transpose, the matrices are symmetric matrices. Okay. See, we will get some example. Okay. So transpose of matrix should be equal to the same matrix. 1, 3, 4, 4. How can we write the transpose of this matrix? Suppose this is A. What is the transpose of this matrix? Transpose. The first row, this first row will be written as first column 1, 4. And for second row, it's 4, 3. It is written as second column 4, 3. You can see that both these matrices are equal 1, 4, 4, 3, 1, 4, 4, 3. That is A is equal to A transpose. That is why. So we can say that these matrices are what? Symmetric matrices. Okay. For a 3 cross 3 example, we can take suppose 1, 3, 7, 6, 6, 8, 8, 2, 2. Suppose this is matrix A. So what is the transpose of this matrix? Transpose of this matrix. See, diagonal elements are not going to change their position. Therefore, we can write them as it is, or we can simply follow basic thing. What is this row? What is the row? First row is 168. We will write it as 168. First row it is written as first column. Then second row is written as second column. That is 6, 3, and 2. And last row is written as last column. That is 6, 2, 7. If you look closely, sorry, 8 to 7. 8 to 7. So what you can say here? This A is equal to A transpose. Therefore, A is symmetric matrix. Okay, A is symmetric matrix. Now, inverse of a matrix. What is inverse? A. Suppose A matrix is given. So how do you find inverse? A inverse is equal should be equal to I. So if you multiply, suppose see A into B, if you get A into B is equal to I, then you can see that this B is inverse of that matrix. Well, when do you say that an element is inverse of some element? Is if you multiply them, you get multiplicative identity. Okay, multiplicative identity. when you multiply two matrices, suppose they are A and B, and you get I identity matrix, then we can say that these two are these two are inverse of each other. So that is B is inverse of A, or A is inverse of B. Generally, when we have to find A inverse, we write it as A inverse is equal to I, and then we use some methods to find A inverse. Sometimes we use reduction method, or what is the formula for finding A inverse? That is, it is A inverse is equal to what? 1 upon determinant of A into adjoint of A. What is A inverse is equal to 1 upon determinant of A into adjoint of A. This is a formula to find A inverse. Another way we can find is using cofactor matrix. Okay, you can use a reduction method as well. Here, A inverse. Suppose what is A? Here you can see. Here you can see that this, this matrix was given A. A was 3 1 2 0. But when you multiply it by this matrix, when it is multiplied to A, you get 1 0 0 1. 1 0 0 1. What is it? This is identity matrix. Identity matrix. When you multiply a matrix by some other matrix and you get identity matrix as a result, you can say that this matrix is definitely inverse of that matrix, A inverse. Okay, next. Here are some properties of inverse matrices. See, AB inverse is, sometimes you can mistake this for AB inverse is equal to what? AB inverse is equal to A inverse B inverse. See, this is not true. Okay, this is not true. AB inverse, these two matrices are given. If two matrices are given and you want to find their inverse of their multiplication, you can simply find inverse of each matrices separately and then multiply them by in this manner. Okay, B inverse into A inverse, not this A inverse B inverse. This is false. Okay, so if you have to find the product inverse of a product, you have to follow this method. So what is A inverse? Inverse of A inverse, it is again A. Okay, transpose, inverse of a transpose matrix. What is the inverse of transpose matrix? It is similar to transpose of inverse. What do you say? This inverse of transpose is transpose of inverse. So for this, suppose you have to, if a matrix is multiplied by a scalar, and you have to find the inverse of this matrix, you can just simply find the inverse of that matrix, and then you have to just divide that matrix inverse by that scalar k. This is both similar. You don't have to just multiply that matrix and then you have to find the inverse. You just find the inverse of that matrix and then divide the whole matrix by k. You will get the same answer. Okay, now determinant of matrix, you have learned this already. What is determinant of matrix A? See, this is A, then determinant of A is equal to, how do you say this? 1 into 5. 1 into 5, it is 5, minus 2 into 6, it is 12, minus 7. So that's how you find determinant of 2 cross 2 matrices. Now how do you find the determinant of 3 cross 3 matrix? Let's take an example here. 2 3 4 2 1 2 3 2 1. Suppose this is matrix A. What is determinant of A? How do you find the determinant of 3 cross 3 matrix? How do you find it? So first we will take this element, write it here 2, and what is the position of this element? It is first row, first column. What is the position? First row, first column. We will delete first row and first column here. So what is remain? 1, 2, 2, 1, and we will take determinant of this matrix. That is 1 into 1, it is 1, minus 2 to the 4. Then we will take this element. We will write minus 3. The second element should be is taken negative. Okay. The first element plus, then minus plus. If it is 4 by 4 matrix, you will follow the same sequence. Okay. This will be plus. This is minus. This plus. Then minus. Then plus minus for nth in order matrices. So see, this 3 is taken minus 3 into bracket. Now we will delete this column and this row. So 2 into 1 it is 2, minus 2 into 3 it is 6. Last element is plus 4. So 2 into 2 4, minus 1 into 3 3. That is equal to 4. 1 minus 4 it is minus 3. 2 into minus 3, minus 3 into 2 minus 6 is minus 4, plus 4 into 4 minus 3 it is 1. So 2 minus 3 is minus 6, minus 3 into minus 4 it is plus 12, plus 4 into 1 it is 4. Therefore this 12 plus 4 it is 16, 16 minus 6 it is 10. Therefore determinant of A is equal to 10. That is the way to find determinant of a 3 cross 3 matrices. You will be asked to find determinant, or you have to find determinants only for 2 cross 2 matrices or 3 cross 3 matrices. Okay. 4 cross 4 matrices are not asked in your exam. So minors. What are minors? Minors of elements. Suppose this is your matrix 2, 3, 4, 7. Suppose this is matrix. What? Aij. What is Aij? What will be the minor of Aij? What will be the minor of Aij? So you just have to delete. Suppose A1j, minor for A1j, it is minor for sorry A12, minor for A12. So this suggests the number of row and this suggests the number of columns. So you just have to delete first row and second column. So 1 2, there was first row, second column. So minor will be 4. Okay. What is minor? M12. We write it as M12. M12 is 4. Similarly, if you have to find M22, what is M22? Second row, second column. Second row, second column. When you delete second row, second column, you get 2. That is M22 is equal to what? 2. That is how you find minor of matrices. See. See here, for a 3 cross 3 matrix, suppose this is 3 cross 3 matrix, A11, A12, A13, A21, A22, A23, A31, A32, A33. This is your 3 cross 3 matrix. So how to find M12? How it is find? M12, what it suggests? Delete first row and second column. So what do we get? All the remaining elements are what? A21. See here, it is written here A23, A23, then A31, and then A33. That's how you find minor of any element. Okay. What is, now see here, M13. What is 13? This 1 means it's a row, number of row, and 3 is the column. Okay. Column. So 1 3 means what? You have to delete this first row, delete this first row, and delete the third column. Okay, what do we get? This matrix A21, A21, A22, A31, A31, and A32. Determinant. If you find the determinant, how do you find determinant? A21 into A32 minus A22 into A31. You will get M13. Okay. Next, cofactor. Now, what is a cofactor? We will take two examples. Okay, see, m12 is equal to 5 and m13 is equal to 7. Now for this, corresponding cofactor will be c12. How to find c12? See this, minus 1 raised to this 1 and 2, these are added, 1 plus 2 into what? This mij. See this, here formula is given, Cij is equal to what? Minus 1 raised to I plus j into mij. Okay, so M12, what is M12 here? For C12, M12 should be calculated already. Okay, what is it? 5. Here it is 5 and minus 1 raised to 1 plus 2. So what is 1 plus 2? It is 3. So minus 1, minus 1 cube. What is minus 1 cube into 5? Minus 1 cube is, it's very easy to find. If minus 1 raised to something is, some number is even, it is 1, and if minus 1 raised to it is odd, some number is odd, then it is odd. Minus 1 to the power of a number that is even, then it is, its value is 1. If the power is odd, its value is minus 1. So it is, here it is, the power is odd, therefore we can say that this is minus 5. For this, m13 m13 cofactor c13 is equal to what? C13. What is C13? Minus 1 raised to this 1 and 3 are added. 1 plus 3 into M13. What is M13? Minus 1 raised to 1 plus 3 is equal to what? 4. So this is power even. So minus 1 raised to even power is 1. Therefore only M13 will be enough for this. M13 is 7. Therefore C13 is equal to 7. You just have to remember what? If the position is like this, their addition is even, then same minor will be cofactor, and if their power, addition of their power is odd, the negative of minor is the cofactor. So again, one other example is, first example is determinant. What is determinant of a? How do you find determinant? 3 into 2 it is 6, minus 1 into 1 it is 1. Yes, 6 minus 1 is equal to 5. Okay. In this example, see, determinant of A for a 3 cross 3 matrix. So we have already learned this. How to write this? First you write 1, then you delete first row and first column. First row and first column is deleted, and determinant of remaining elements is taken. Okay. So 2 into 1, 2 into 1 it is 2, minus 3 into 0 it is 0. Then second element should be with the sign negative. Okay. Minus 0 into, so minus 0 it is the product will be 0, so no need to write in what is inside the bracket, plus 1 into what? 1. So you will delete this first row and third column, so 0 into 0 it is 0, minus 2 into minus 1 it is minus 2, that is plus 2. So if you add this, 2 minus 0 it is 2, 1 it is 2, minus 0 plus 0 plus 2 it is 2 plus 0 is 2, 2 into 1 2, that is 2 plus 2 is equal to 4. That is how you calculate determinant of a matrix. Cofactor of matrix, we have already seen this. How to write cofactor? See, for this matrix, first we will find C11. How do you find C11? We have already seen this, minus 1 raised to 1 plus 1 M11, that is equal to minus 1 square into what is M11. So while finding M11, you have to delete first row and first column. Sorry, first row and first column you have to delete. So what is remain? 4, which is equal to minus 1 square, it is 1 into 4 is equal to what? 4. Now to find 1 C12, how to find? C12 minus 1 raised to 1 plus 2 into M12 minus 1 raised to 1 plus 2 into M12. That is, so again you can see that the power is 3, therefore it is minus 1. So you directly have to write minus and then M12. What is M12? First row, second column, that is minus 3. Minus of minus 3 is 3. Then C21 for second row, first column element. What is hmm. For a second column, first row element? Sorry, second column, second row, first column element for this here. Second column, first row element, minus 1, 2 plus 1, minus 1 raised to 2 plus 1 into M21. What is M21? So again here 2 plus 1, that is 3. So therefore the power is odd. Therefore minus 1 raised to odd power is minus. M21 means 2. Then C22. What is C22? Again it is minus 1 raised to 2 plus 2 into M22. So minus 1, this power is 4. Therefore minus 1 raised to even power is positive 1. Therefore M22 will be the answer for C22. M22, what is M22? Second row, second column, if it is deleted, you get 1. 1. You get 1s. Therefore if you write this, C is, what will be C? 4, 3, minus 2 and 1. That is 4, 3, minus 2 and 1. Okay. Now we will see some example on matrices that are previously asked in your exam. Okay. All these are previously asked in CET exams. Okay. So here, what is given? A is given here, and you have to find the minor of A11. What is minor of A11? See here, A11 means what? First row, first column. You have to delete first row, first column. What is remained? A22. A22. So that is your answer. See here, one thing to remember, that minor is asked in this example. What is asked? Minor is asked, not cofactor. If cofactor is asked, you will write minus 1 raised to what? Here 1 plus 1. What is 1 plus 1 into M11? So here nothing will be changed. Okay, 1 plus 1 is equal to 2. Therefore it is again plus M11, that is A22. The answer will be same, but you have to just remember this. Okay, minor and cofactor are two different things. Cofactor is calculated using this. Okay, now M21. What is M21? Second row, first column, minus 1. Okay, minus 1. That is how you calculate minor. And M23. See, for 3 cross 3 matrices, how to calculate M23? So this 2 is row number. So this is deleted. 3 is column number. This is also deleted. Therefore, what we get? 1, 1, minus 1 and 2. Determinant of this is 1 into 2, it is 2, minus 1 into 1. What is minus 1 into 1? It is minus 1. Therefore 2 minus minus 1 is what? 2 plus 1, that is equal to 3. Okay. The minor of the element. Then the minor of the element A31. What is asked? Minor of A31. 31 means third row, first column. So you have to calculate the determinant of 2, 3, 4, 2. What is the determinant of 2, 3, 4, 2? 2 into 2, it is 4, minus 3 into 4, it is 12. So my 4 minus 12 is minus 8. Therefore this is the answer. Now it is here cofactor is asked. Okay, all these are previously asked in CT examinations. A21, see this A1, A sorry, A12. 12 means first row, second column. Delete first row, delete second column. What do we get? Minus 3. Remember, M12 is calculated. What is M12? M12 is minus 3. How do you calculate C12? C12 is minus 1 raised to 1 plus 2 into M12. So minus 1 cube into minus 3. So see here. Here it is odd power. Odd power, therefore you will write minus of minus 3 is 3. So answer will be 3. You should not get confused between minor and cofactor. Okay, this is minor, this is cofactor. You don't have to calculate all this. Just find minor and understand what position is asked. Okay, 1 2 is asked. 1 2, 1 plus 2 is 3. If odd is asked, you write, you take negative of this minus 3. Negative of minus 3 is 3. If position is 2 2, so addition of this is 4. 4, it is even. Then you just directly write this answer. Okay, cofactor of A21. 21 means second row first column. Delete second row first column, you get 3. That is minor. Minor is 3. Now A21, see A21, 21 addition of them is 3. 3 is odd. Odd means minus. So you get answer is minus 3. Next, cofactor of A32. Third row means this row. Delete this. And second column. Second column means this column. Okay. Third row, second column. Now then 2 into 5 it is 10, minus 3 into 4 it is minus 12, that is minus 2. See this is minor. Minor is equal to minus 2. Now what you have to calculate? This 3 2 is 3 plus 2 is equal to 5. 5 means odd. Odd implies minus. Therefore minus 2, minus of minus 2 it is 2. Therefore answer will be D. Adjoint. Adjoint. See, how do you find adjoint of a matrix? Adjoint of 2 cross 2 matrix. You don't have to calculate. Okay, there is one short trick for this. How do you find adjoint of A? Therefore A, matrix A, what is matrix A? Minus 1, 5, minus 3 and 2, it is A. What is adjoint of A? Sorry, adjoint of A. What is adjoint of A? See this. These two elements, you have to interchange their positions. Okay, so minus 1 will be written here and 2 will be written here. And for these two elements, you have to change their signs. So 5 becomes minus 5, minus 3 becomes 3. This is the simple way to find adjoint of a 2 cross 2 matrix. There is another way for finding adjoint of a 3 cross 3 matrix that will be solved in some further examples. Okay, but this is the way to find the adjoint of a matrix that is of order 2 by 2. You just have to interchange these two values, these diagonal values, and you have to change the signs of these two values. Okay, so what will be the answer? C. C will be the correct option. Okay, next example. Here you have to find adjoint of 3 cross 3 matrix. How to find the adjoint of 3 cross 3 matrix? See, very easy way to, first you have to write the same matrix here. Okay, 1 0 0, 3 3 0, 5 2 and minus 1. Okay, so okay, sorry, not like this. Okay, first you write transpose of this matrix. Okay, transpose of this matrix. So how do you write it? 1 0 0. So what is the first row here in this matrix? Row is 1 0 0. We write it as column. Then 3 3 0, 3 3 0, What is the last row? 5 to minus 1, 5, 2 and minus 1. So we write the transpose of this matrix. Then what you have to do? These first two columns, write it like this. Okay, write them like this: 1 0 0. Repeat them here. Okay, 3 3 and 0. This. Okay, these two columns are repeated here. Okay, now repeat these two rows at the bottom. Okay, 1 3 5 1 3 1 3 5 1 and 3. Repeat this line at the bottom: 0 3 2 0 3. Okay, after this delete these two lines. Okay, these two lines delete. Now what is, now we will find adjoint of A. How do you find adjoint of A? See, you have to take determinant of these elements in this manner. Okay, so 3 into minus 1 it is minus 3, and 3 into minus 1 it is minus 3, 2 into 0 it is 0. Therefore adjoint is minus 3. Then same, 2 into 0 it is 0, 0 into minus 1 0, 0 minus 0 is equal to 0. Then for this element, 0 into 0 it is 0, minus 1 into 5 into 0 it is 0. So minus 1 into minus 1 minus 0 it is minus 1. Then 0 3 1 0. So 3 into 0 it is 0, minus 0 into 1 it is 0. 0 minus 0 is equal to again 0. Now for the last row, we will calculate the determinant in last columns. Okay. Then therefore 3 into 2 is equal to 6, minus 5 into 3 it is 15. What is 6 minus 15? It is minus 9. For second element of third column, sorry, is third row, find this. Okay, 5 into 0 it is 5. Sorry, 5 into 0 it is 0, minus 1 into 2 it is 2. 0 minus 2 is equal to minus 2. Now for this, calculate this. 1 into 3 it is 3, minus 3 into 0 it is 0. 3 minus 0 it is 3. So that is how you calculate adjoint of matrix A. What you have to do first? Write transpose. First, what we done? We wrote the transpose of this matrix first. Then what we did? We repeated these two columns here. These two columns were repeated at the beginning, and then we repeated these two rows at the bottom, whole rows. Okay, at the bottom, and then we deleted these two rows. This row, first this row was deleted, then this column was deleted, and we used all these elements to calculate adjoint of A. So answer will be this. Okay, this will be the answer. This is, see, we have calculated adjoint of A, but what is formula for inverse A inverse? What is the formula for A inverse? It is 1 upon determinant of A into adjoint of A. Adjoint of A. So if you can calculate adjoint of A very fast, you can calculate A inverse as well. Okay, you have to calculate A determinant of A. So right hand side will be solved, and you will get A inverse in quickest way. Okay, here you have to calculate A inverse. What is A? A is equal to what? 2, 3, 4 and 6. Again, what is A inverse? We just saw that A inverse is equal to A 1 upon determinant A into adjoint of A. Okay, 1 upon determinant A into adjoint of A. But what is adjoint of A? How can we calculate adjoint of A directly? So adjoint of A is, see again, these 2 and 6, their positions are interchanged. So 6 comes here, 2 goes here. Okay, and this 4 and 3, their signs are changed. Okay, 3 becomes minus 3 and 4 becomes minus 4. What is it adjoint? This is adjoint of A. See, so what is, how to calculate this? 1 upon determinant of A. Now we have to calculate determinant of A. What is determinant of A? A is, this is A, this is your A, and determinant of A, 6 into 2 it is 12, minus 3 into 4 it is 12. See, this should have been calculated in the very first place. Okay, so 12 minus 12 is 0. So determinant of A is 0. So there is no need to calculate adjoint of A. Why? Because when determinant of A is equal to 0, A is not invertible, isn't it? It is not invertible. So D. The answer will be D. A inverse does not exist. Multiplicative. Now see, here we will use that. Okay. Multiplicative inverse of matrix A. What is multiplicative inverse means? We have to find A inverse of this matrix. So what is formula for A inverse? 1 upon determinant of A into adjoint of A. So determinant of A is equal to 2 into 4. 2 into 4 it is 8, minus 1 into 7 it is 7. Therefore determinant of A is equal to 1. And how do we find adjoint of A? We just computed adjoint of A for a matrix in previous example. How do you calculate adjoint of A? This 2 and 4, they will interchange their places. The 4 comes here, 2 goes there, and 1 and 7 will have negative signs. Minus 1, minus 7. This is adjoint of A. Therefore A inverse is equal to what? 1 upon determinant A into adjoint of A. Adjoint of A. What is determinant of A? It is 1. Adjoint of A is 4 minus 1 minus 7, 2. That is 4 minus 1 minus 7, 2. This will be the answer. 4 minus 1 minus 7, 2. A. A will be the correct option. Inverse of the matrix. In similar way, you can calculate inverse of 2 cross 2 matrix as well. So how to calculate this? What is determinant? First we will calculate determinant. Every time you get asked to find the inverse of any matrix, you have to calculate determinant of A. If it is 0, you don't have to go for further procedure. Okay, if it is not non-zero, then the matrix is invertible. Therefore you have to find adjoint of A and then use the formula. Okay, so determinant of A is, here determinant of A is 3 into 4 it is 12, minus 2 into 1 it is minus 2, that is 12 plus 2 it is 14. 14. Therefore determinant of A is 14. Now adjoint of A is equal to adjoint of A. Very easy to find. This 3 4, they will interchange their places. 4 sorry, see here 3. So these 3 and 4, they were interchanged. So 4 and 3, they become 4 and 3. Therefore 4 2 minus 1 3. 4 2 minus 1 3. There, this one is the correct option. See, this 14 is multiplied to every element. 1 upon 14 is multiplied to every element, or 14 is divided to every element inside the matrix. That is why the matrix looks like this. Okay, next. See here, what is given? ABC not equal to 0. So when ABC is equal to 0, see, ABC is equal to 0, determinant of A will be 0. That is why it is given here. Okay, therefore matrix, if determinant A is 0, matrix will not be invertible. Now we have to find A inverse. See this. This is a diagonal matrix. All other entries are 0. So therefore this is a diagonal matrix. So how do you calculate the inverse of this matrix? You just have to calculate this. Okay, 1 upon A, 1 upon B, 1 upon C. This is inverse of this matrix. Okay, A inverse is directly found like this. Okay? Suppose 2 3 and 5, 0 0 0 0 0 0. and you are asked to find, this is, suppose this is A, and you are asked to find A inverse. A inverse is equal to what? Okay, what is A inverse? It is 1 by 2, 1 by 3, 1 by 5. All the other entries, they should be zeros. You can directly find A inverse of these elements. Okay, now see again, these two entries are 0, therefore again this matrix is diagonal matrix. Diagonal matrix. Okay, how to find the A inverse? See this A becomes 1 by A, and 1 by B becomes B. Okay, what is 1 upon 1 by B? What is 1 upon 1 upon B? It is B. Therefore this is the inverse of the given matrix. Okay, so correct option will be C. It's inverse of matrix this. Now see, this is a difficult example. Okay, so how do you find the inverse of a 3 cross 3 matrix? Again, we will use the same formula. Okay, what is our formula? A inverse is equal to 1 upon determinant of A into adjoint of A. Now we first have to calculate determinant of A. So for determinant of A, see this first element 3, then 1 into 1 it is 1, minus 1 into 0 it is 0, 0. Therefore minus 2, that is plus 2. So this row and this column will be deleted. Therefore minus 4 into 1, what is minus 4 into 1? It is minus 4, minus 2 into minus 1. What is 2 into minus 1? Minus 2, minus 2. Therefore it becomes plus 2, minus last element minus 1 into bracket, minus 4 into 0 it is 0, minus 2, 2 into 1 it is minus 2. Therefore this is equal to 1 minus 0 it is 1, 1 into 3 it is 3, plus minus 4 plus 2 it is minus 2, minus 2 into 2 minus 4, minus 4, 0 minus 2 it is minus 2, minus 2 into minus 1 plus 2, plus 2. Therefore minus 4 plus 4, this will be 0. The answer will be determinant of A is equal to what? 3. Now we will find adjoint of A. So I already learned how to find adjoint in simple way. Okay, so first matrix, this is the matrix given in the example. Okay, we will write its transpose. How do we write it? 3, first row will be written as first column, 3 minus 2, sorry, 3 minus 2 minus 1. Then second row will be written as second column, so minus 4, 1, minus 1. And third row is 2, 0, 1. So just repeat first two columns at the right hand side. Okay, 3 minus 2 minus 1, and minus 4, 1, minus 1. And repeat these two rows at the bottom. 3 minus 4, 2, 3 minus 4. And again this line, see this line we read second column here. This is the first step. Then this repeating the rows is the second step. Here we write minus 2, 1, 0, minus 2 and 1. Now we will delete this first column and first row as well. Therefore adjoint of A is what? We will have to calculate this. Okay, 1 into 1 it is 1, 0 into minus 1 0, 1 into 1, therefore it is determinant of this is 1. Now we calculate this, 0 into minus 1 0, minus 2 into 1, that is 2. Then for third entry, minus 2 into minus 1 it is 2, minus 2 into minus 1 it is 2, minus 1 into 1, minus 1 into 1 it is minus 1, therefore the plus 1 is equal to 3, that is 1 2 3. Then for second row, minus 1 into 2, what is minus 1 into 2? Minus 1 into 2 is minus 2, minus minus 4 into 1 it is minus 4, that is plus 4, that is 4 minus 2 is equal to 2. Now for second element, 1 into 3 it is 3, and minus 1 into 2, minus 1 into 2 is equal to minus 2, that is 3 minus 2 is equal to 1. Similarly, we can calculate the remaining elements. All the remaining elements you have to calculate, and you have to use this formula, 1 upon determinant A into adjoint of A. So what is determinant? 1 upon 3 into adjoint of A. So this matrix. This will be the answer. Okay. You calculate, do it yourself. If matrix A, again here, what is given? Matrix A is given. Okay. Matrix A is given, and what is given here? A inverse here. Look carefully. Okay. What is given? A inverse is equal to 1 upon K adjoint of A. But we know that what is the formula? A inverse is equal to what? 1 upon determinant of A into adjoint of A. So now compare this. What do we get? See here. Here it is A inverse, here A inverse. Adjoint of A, here also adjoint of A. But 1 upon K is equal to 1 upon determinant of A, which means that K equal to what? K is equal to determinant of A. Therefore, you just have to find determinant of A. So, what is the determinant of A? How to find it? Determinant of A. So, this is A. So, for 3, first row, first column, 3 into bracket, 2 into 1, it is 2, minus 1 into minus 1, it is minus 1, that is plus 1, minus 2, 1 into 1, it is 1. So, for this element, 1 into 1, it is 1, and minus 1 into 0, it is 0, plus 4 into bracket what? 1 into 1, 1, minus 0. So 3 into 3 minus 2 plus 4. So 9 minus 2 plus 4. What is the value? 9 minus 2, it is 7. 7 plus 4 is equal to what? 11. So answer will be D, 11. Next question, A. A is given. A inverse is to be found here. Okay. So how can we find that? A inverse. A is given. So similarly, same way, 1 upon determinant of A into adjoint of A. So what is determinant of A? 2 into 6. 2 into 6 is equal to 12, minus 3 into 4 is equal to 12. See here. Again, 12 minus 12 is equal to 0. Therefore, we have to mark this option. Okay. This option should be given in the exam. Okay. It does not exist. The A inverse what? It does not exist since matrix is singular. No. See here, A matrix A is given, matrix B is given, and AB transpose. We have to find AB transpose. So first we have to find AB. How do we find AB? See this matrix. Order of this matrix is 2 rows are there and 3 columns are there. In this matrix, 3 rows are there and 2 columns are there. Therefore, these 3 and these 3 they match. Therefore, matrix in multiplication is possible, and resultant matrix will be of order 2 cross 2. The order of this matrix will be 2 cross 2. Therefore, there will be 4 elements. So, a position of this element is 1 1, A 1 1. So, first row, first column. Therefore, first row and first column first. 1 into 2 it is 2, minus 2 into 3 it is minus 6, 1 into 1 it is 1. Then for first row, second column, 1 into 1 it is 1, minus 2 into 2 it is minus 4, and 3 into 1 it is 3. Now second row, for second row elements, second row, first column, that is 2 into 2 it is 4, 1 into 3 it is 3, and 3 into 1 again 3. For second row, second column, 2 into 1 it is 2, 1 into 2 it is 2, and 3 into 1 it is 3. So what will be the result? 3 minus 6, it is minus 3, 0, 9, sorry, 10, and 2 plus 2 4 plus 3, it is 7. So first row second column, is it correct or not? First row, second column, 1 into 1 it is 1, minus 2 into 2 it is minus 4, 1 into 1 it is 1, 1 into 1 it is 1. Okay, so 1 plus 1 is equal to 2, and here it is minus 2, minus 3, minus 2, 10 and 7. Therefore correct option will be this. No, 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 this is what we just find. We found AB, we have to find AB transpose. Then what is AB transpose? So first row will be written as first column, that is minus 3 minus 2, and 10 7 will be another column, 10 7. Therefore minus 3 10 minus 2 7. This will be the correct option. Okay, this will be the correct option. We are not asked to find AB, we have to find AB transpose of that matrix. So you have to find transpose and then give answer. Now see, omega, if omega is a complex cube root of unity and A is equal to C. What is omega? Omega is complex cube root of unity. It is cube root of unity. And A is equal to, given this, A is equal to this, okay, A raised to 50. And we have to find what is A raised to 50. Okay, see, A raised to 50. A raised to 50. You have to just, what you have to give, right? A raised to 50 means 16 into 3 plus what? 2. What is 16 into 3 plus 2? See this, 16 into 3 it is 48 plus 2. Cube root of unity. See the, you have to write this in form of some number into 3. Okay, cube root of unity. Therefore 16 into 3 plus 2, that is A raised to 48 plus 2. And this number, that will be your answer. Omega square A. Okay, if it is A raised to 51 or 50, A raised to 50, suppose it was A raised to 50, see, this is A raised to 50, therefore 48 plus 2, that is 48 plus 2, 16 into 3. You have to write in the form of multiplication of 3. Okay, so plus 2, this plus 2 determines that the answer is omega square into A. See, A square. Now A is given like this and we have to find A square. So A is equal to what? 0 to 2 0. So just multiply this, 0 to 2 0, 0 to 2 0 into 0 to, okay, wait, 0 to 2 0, 0 to 2 0. Multiply this. Okay, first row first column, 0 into 0 it is 0, 2 into 2 it is 4. In first row second column, 0 into 2 it is 0, 2 into 0 0. Then second row first column, 2 into 0 0, 0 into 2 0. So here 0. Again 2 into 2 4, 0 into 0 0. Therefore so simply the answer is 4004. Okay, next, see, we have studied this. Okay, in the introduction and introduction of matrices. If A and B are non-singular matrices, then what? AB inverse is equal to what? We see AB inverse is equal to what? B inverse A inverse. Okay, B inverse A inverse. AB inverse is equal to A inverse inverse. See, this thing is not possible every time. This also, all these cases are not possible. Sometimes they are possible, but not always. But this is true, universally true. Okay, so here two linear equations are given. What are the equation? X plus 2y is equal to 3 and 2x plus 3y is equal to 4. Okay, you are supposed to solve this by using matrices, but you need not to do that. You just use elimination of coefficient method and directly solve this. You don't have to solve this by matrices. So then transpose. Next example. Adjoint of x is transpose. What is it? Ask this adjoint of x. First we have to find adjoint of x and then we have to find transpose of it. Okay. Then we have to find transpose. So first we will find adjoint of x. So what will be the adjoint? Adjoint of x. What will be the adjoint of x? See, these two elements will be interchanged. Okay. So here comes t minus x is written here, and minus y and z they change their sign. The minus y becomes y and z becomes minus z. So that is adjoint of x. So what is transpose? Adjoint of x and its transpose is what? Transpose means rows are written as columns and columns are written as rows. So this first row will be written as column, second row will be written as second column, minus z minus x. So t minus z, y minus x. The answer will be this. X. Adjoint of AB. AB. Now we have to what find? We have to find adjoint of AB. So therefore we first have to find AB. What is AB? AB is equal to what is 3 into 6, it is 18, plus 2 into 8, it is 16. Then again 3 into 7, it is 21, plus 2 into 9, 18, divided by 7 for second row, first column, 7 into 6. Okay, 3 into 6, 18, plus 2 into 8, 2 into 8, 16. Then 3 into 7, 21, 2 into 9, 18. Then for this element, 7 into 6, 42, plus 5 into 8, 40. Then second row, second column, 7 into 7, 49, plus 5 into 9, 45. What is the addition of this? 18 plus 16, it is 34. Second element will be 39. This is 82, and 49 plus 49, it is 94. Therefore this is A B. What is adjoint? Adjoint of AB. Adjoint AB is equal to what? How to find adjoint? We will interchange these two elements. Therefore 94 here, here 34. 39 becomes minus 39. 82 becomes 94 minus minus 82, 34. A will be the correct option. See here we have to find A is given and determinant of adjoint of A is to be found here. Okay, therefore adjoint of A. What is adjoint of A? Adjoint of A is 4 and 4. They will interchange their positions. So 4 and 4, nothing will change. 2 becomes minus 2, 3 becomes minus 3, and determinant of this. What is determinant? 4 into 4, it is 16, minus 2 into minus 3. Minus 2 into minus 3. What is minus 2 into minus 3? It is minus 6. That is 16 plus 6. 16 plus 6, it is, sorry, 6 minus 6. This is plus 6. Therefore 16 minus 6. 16 minus 6, it is 10. Therefore correct option will be B. See now, A into adjoint of A. We have to find A into adjoint of A. Therefore, what is adjoint of A? Adjoint of A is equal to, it is 4, 3 minus 2 minus 1. Interchange these numbers, change signs of these two numbers. So 4, 3 minus 2 minus 1, and we have to multiply A 3 2 1 4 into adjoint of A. What is 4 minus 2 minus 1 and 3? What is this? This is A. This is adjoint of A. The product. This product is asked here. Okay. What is the product? 3 into 4 it is 12. 2 minus 1 minus 2. 12 minus 2 it is 10. Then okay, 3 into minus 2 minus 6. 2 into 3 6. Minus 6 plus 6 is equal to 0. Then 1 into 4 it is 4. 4 into minus 1 minus 4. The 4 minus 4 is equal to 0. Then 1 into minus 2 it is minus 2. And 4 plus 3 it is 12. Minus 2 plus 10 12 it is 10. So 10 0 0 10. So correct option will be this. Okay, this will be the correct option. Now inverse of this matrix. What is the inverse of this matrix? Again we will find adjoint of that matrix. What will be the adjoint of this matrix? 1 minus 1, they will change their positions. Minus 1 1, and sine alpha becomes minus sine alpha, and minus sine alpha becomes sine alpha. This is adjoint. What is determinant of this matrix? Suppose this matrix is A, then determinant of this matrix is 1 into minus 1, it is minus 1 minus sine alpha into minus sine alpha, that is minus sine square alpha, that is minus 1 minus plus sine square alpha. If you take minus sine common, you will get 1 minus minus into 1 minus sine square alpha, which is equal to minus cos square alpha. So A inverse is equal to 1 upon determinant of A into adjoint of A, which is basically 1 upon minus cos square alpha into what is adjoint of A, minus 1 minus sine alpha 1. What is 1 upon cos? What is 1 upon cos? 1 upon cos is equal to what? It is sec. Therefore, minus sec square alpha into bracket what? Minus 1 minus sine alpha into 1. So this, if this multiply this minus sign inside the matrix, we get sec square alpha into 1 sine alpha minus sine alpha 1. So this will be the answer. Which one is the correct option here? Sec square alpha 1 minus sine alpha. Mm, this will be the correct option. This option B will be the correct. C will be the correct option. Now, okay, wait.